By now you've probably already heard about the violently explosive eruption that occurred yesterday evening in the island nation of Tonga. I've read some reports that the blast could actually be heard as far away as Canada, and sure enough, when I checked the barometric pressure weather data at my house, there is a distinct spike in air pressure corresponding to this volcanic eruption. And this is something that is measurable pretty much everywhere in the Pacific. My house is well over 5,000 miles away from this volcano, and it's still very measurable. So Australia, New Zealand, Fiji, Hawaii, California, all of the west coast pretty much, all have a measurable shockwave from this volcano sometime between January 15th and January 14th, with differing times based on the amount of time it takes for the shockwave to actually travel to each location. Now, based on this delay, we can actually estimate the speed of sound. So, for example, I have a random weather station in San Francisco here, looking a little chilly today. And if we go down and look at the barometric pressure, we can see a pressure spike. And this is caused by the eruption, the shockwave, traveling through the atmosphere. So it looks like the shockwave arrived at say 3:49 a.m. Now that corresponds to a 7-hour and 21-minute travel time. This eruption occurred at 7:28 p.m. Pacific time. So if we go into a standard calculator, let's convert that to seconds. So 7 hours times 60 plus 21 minutes times 60 again gives us 26,460 seconds. And if we go into Google Earth, it's pretty simple to calculate the distance. So this is the volcano that actually erupted. And if we go, let's change that to meters. Let's just take the distance from here to San Francisco. Looks like the weather station was around there. We get around 8.5 thousand kilometers. So if we go into our calculator again, 8.5 million meters divided by 26,460 seconds gives us an approximate shockwave velocity of 321 meters per second. This number isn't entirely accurate. If you Google the actual speed of sound, you'll get 343 meters per second. But we're calculating the speed of sound from a volcano. So I think that less than 10% error that we're getting here is pretty good, all things considered. Thanks for watching.